hopefully today. So, starting with the chemistry of life. So, when we are talking about life, that is different than chemistry. When we are talking about something that is alive, our very smallest structure that we can say is alive is a cell. Anything smaller than a cell, we do not consider it to be alive. It's not considered, it's classified as alive. So, a cell is the lowest level of structure in biology. Are we working? Okay, when we talk about chemistry, what is the smallest unit that still maintains the chemical properties of that atom? Dang it, it's an atom. So in biology, our smallest structure is a cell. In chemistry, the smallest structure that still has the properties of a chemical is an atom. Now, when we are looking at cells, majority of cells are made up of 70% or more water. Water is required for life. It's a requirement. It's why when we are searching for life in other areas, we're not necessarily searching for life immediately, right? What are we looking for when we visit other planets, when we are going out into space? What substance are we looking for? Water. So, have you guys, I listened to this book, hold on. It was called The Hail Mary. It's a fictional book. I usually don't like science fiction, but this one caught my eye. I've listened to it on Audible 3 different times because I liked it so much. But it's about this scientist, and this scientist graduates with he's actually a middle school science teacher. So the story starts out, he's a middle school science teacher, but his background is he was a scientist, and he was getting his PhD, and he wrote a paper on if life can exist without water, and the reasons that it could be able to exist without water. And then there's this huge event, and he gets pulled up by the major powers of the earth. They come and they take him out of his classroom, and they're like, hey, 10 years ago you wrote this paper. It said life could be developed without water. We need you in the lab. And anyway, it's a great book. It's amazing. But we know that 70% of cells, this is a bacterial cell, is made up of water, and that means the rest is made up of chemicals. We know that there are a handful of chemicals needed for life, and even fewer of those chemicals make up the bulk of our cells. So the 4 elements that make up the bulk of living cells, over 96% of living cells are made of oxygen, carbon, hydrogen, and nitrogen. This right here, this is the basis of biochemistry. These 4 elements, that's it. That's all we talk about when we talk about biochemistry is these 4: oxygen, carbon, hydrogen, and nitrogen. And of these 4, oxygen comes in strong at 65%, carbon at 18.5%, nitrogen at 9.5%, and hydrogen at 9.5%, and nitrogen at 3.3%. Can I talk to you guys about the Borscht-Hager process? What? No, I must not. Okay, so I just watched this documentary on this gentleman. He was a German gentleman in the beginning of the 1900s, and I don't know if you know anything about population growth, but in the early 1900s, the population growth of the earth was increasing at a rate where our current agricultural processes were not going to be able to sustain enough food for the amount of people that we had being born. The main thing we were missing was nitrogen. We didn't have enough nitrogen in the soil because plants require nitrogen. So what was happening was, because of the farming practices, farmers were planting crops and they were using all the nitrogen in the soil, and then that land would just be dead. You couldn't use it to plant anything because nothing would grow there because all the nitrogen was gone. So this German guy is like, hey, there's all kinds of nitrogen in the air. Surely we can come up with a process where we can fix nitrogen in such a way we can take nitrogen from the air and we can put it into the soil. Anybody have a farming background? Anybody know what they put on the fields? Yep. But what kind of chemical specifically? Anhydrous ammonia. Very good. Anhydrous ammonia puts the nitrogen back into the soil. This is when the early 1900s 1920-ish. And so this guy came up with this process to be able to spray this anhydrous ammonia onto the soil. Now they're saying approximately 80% of the nitrogen found in your body comes from his invention of the Borscht-Haber process that takes nitrogen and hydrogen from the air and puts it into ammonia in a form that we could put on the ground. Side note, he was nominated for the Nobel Prize, and all the other Nobel laureates refused to attend this ceremony because at the time World War I had broken out, and this guy was a brilliant chemist. He was also the inventor of nerve gas. So nerve gas, which is a highly deadly gas that is heavy, and they would release this gas, and then when the wind was blowing correctly, it would blow across the field and then settle into the trenches of the opposing forces. So first, the invention of chemical warfare. So same guy invented both. So they were protesting his nomination.
That's genius.
Don't they also rotate different crops to put nitrogen in the soil?
Yes, there are crops that can fixate nitrogen into the soil. Yes, that is why we rotate corn and beans typically on a rotation. Corn requires more nitrogen. Beans will fixate nitrogen into the soil. Great point. Okay, so these are our main chemicals required for life. This looks terrible.
How does it look?
Not to be.
Looks fine on ours.
I think he did something wrong.
I didn't do anything wrong. It's not my PowerPoint. I just pushed play. All right. So, an atom is made up of a nucleus. All right, class. Inside the nucleus of an atom, we have what?
Protons.
Good job. Not to be confused with the nucleus that is inside a cell. So we have protons and neutrons. There is one element that does not have any neutrons in its natural form, and that is hydrogen. Very good. So our four elements, if we look at them like what they look like on the atomic table, we have hydrogen, carbon, nitrogen, and oxygen. In this format, our top number is the atomic number. Our bottom number is the atomic mass. Remember that atomic number is equal to what particle in the atom? Proton. Very good. And our atomic mass is our protons and our neutrons together, added together to make up the mass. Why are the electrons not included, Isaac?
They don't weigh them.
They don't weigh very much. That's right. They are very small. I think it's 1,820.
I have it written down.
Because I'm a chemistry teacher.
It's 1/2000th of a proton.
1,820. Yeah. 1/2000. Same idea.
Yeah.
Yeah.
Good job.
What?
I said,
Yep. All right. So, remembering that we are going with the quantum model of the atom, which is the nucleus with the cloud of electrons orbiting around it based on probability, and the probability that the electrons are going to be at a certain place at a certain time, they form this cloud. Question for you. Why, when we're looking at this cloud, it looks like the area right around the nucleus is a little bit lighter? Why would it look like that, Brayden? Yeah, so they want to be as close to the protons as possible, but as far away from the other electrons as possible at the same time. So it's like they're attracted, but they don't want to get too close. It's kind of like when you get to a party and you're like, oh, I want to join the people, but I don't want them to touch me, right? Same idea. So that is why they're not all like clinged onto the nucleus, is because they want to be close to the positive particles, but they don't want to be this close to touch. All right, let's do this slide real quick. So atoms interact and form chemical bonds dependent upon their electron configurations. These levels hold a specific number of electrons. The first ring around the nucleus holds 2 electrons. The second ring around the nucleus holds 8. And the third ring around the nucleus holds 18 electrons. And the electrons in the outermost energy level are shared to form a bond. What are the outermost electrons called, Danielle? Valence electrons. Excellent job. Those valence electrons are the ones that do all the work. They are shared to form bonds, or sometimes they give them away or accept them. And we will get into the rest of this tomorrow. We're going to stop there. No time.
That's a great question.
10:30. Yay, you guys did good.
So good.
If you were a quiz,
it in and not say anything?
Disregard.
You guys, you grade them, I'll put them in.
I don't think you'll be grading or entering grades for your own class. I think that's okay. You're gonna have plenty of grading to do today on your
labs.
labs.
I take your laptop and do it the other day, but I wrote down.
No, you're fine.
I can know what you're doing about
What's wrong with your calculator?
No, mine was
Oh,
really expensive. I've never used it.
you've never used a regular calculator?
I didn't really need it.
I know, I haven't read since school started.
I don't disagree. Yes.
Was the notes for that reading?
Yeah, it's all the same. It's like a while.
Like
on the
very
kind of like a big.
I think I kind of lied about that though, because it's actually part of this. It's chapter 3.
Knowing the last.
I didn't realize that chapter 3 was macromom. I have to look at it.
I hate reading and taking notes.
You do? Yeah, it's horrible.
It's boring. It's boring.
No, it's horrible because I write everything down. It's 10 years.
Yeah, it takes me like so long to do it. And
So
literally
here's the
it's
thing.
like, yeah, I read it in 30 minutes.
Like in college, this is what
I
they
know,
say
I have
about.
to do it all the time.
Well, this is what they say about college classes. For every hour spent in class, you have to spend 3 hours outside.
So
I
many.
know. I don't have 3 hours outside of class.
I did
Not
not
in the high school class.
Daily?
but For every hour spent in class. So we're
So
saying
I don't
like,
think I'm
you
mad
have
at
a
that.
3-hour class where you go Monday, Wednesday, Friday.
No.
In class, you go 3 hours in
9
class.
hours a week.
Yes, so you would spend 9 hours outside of class.
Okay, I was like, I've been there for 1 day. I've done
So
9 hours.
if you're taking 15 credit hours, you would spend 45 hours outside of class per year.
That's reasonable. Kind of. I definitely did not.
You're not gonna be saying that in college.
Well, here's the extra. Whose is this?
Someone didn't
Yeah,
grab
the
one.
only thing is you like 3 classes.
Is he Braden? There wasn't an extra. I only got 4. I'm sure I only got 4. Izzy, it's yours.
No, it's not. No, Izzy has hers. It's water. Goodbye. Have a great day. I'll see you tomorrow. Hello.
Do we need to turn our lab?
Pardon?
Do we turn in our lab?
No, I'm taking that lab as a laundry. How was it? No, she didn't hear me. Okay, this is not for you. Oh.